In this video, I will show you how to prove that shape ABCD is a trapezoid using coordinates. Okay, so we're told that ABCD is a trapezoid. Let's check off everything that applies to a trapezoid. Does it have two pairs of parallel sides?
No. Yes. No.
No. We're not going to check that one. It has exactly one pair of parallel sides?
Yes.
Yeah, that's what a trapezoid is. That's the definition of a trapezoid right there. All four sides congruent?
No.
No, that's a rhombus. Has exactly one pair of congruent sides?
No.
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 Not congruent sides. Parallel
No.
sides. Okay. Both pairs of opposite sides are congruent? No, that's a parallelogram thing. Two pairs of consecutive sides congruent, but not that's a kite. There are right angles at all four vertices? Nope, that's a rectangle. The diagonals are perpendicular? Nope. The diagonals are congruent? Nope. The diagonals bisect each other? No. All right, a trapezoid is the one shape that doesn't have any properties of the diagonals. It has no special properties. Okay? So we're going to have to run with the only thing we've got. The definition of a trapezoid is exactly one pair of parallel sides. So use calculations and words to show that the quadrilateral meets the definition of a trapezoid. Yesterday I warned you guys that whenever it says use calculations and words, that is your signal that I'm looking for what three things? That's right. I'm looking for an introduction, a main body, and a conclusion. All right? So that includes your homework, like right now, and on the test. I'm going to color coordinate these, so I'm going to put my introduction in blue. Okay? So we're supposed to prove that this is a trapezoid. Feel free to type this, especially if you write really big. I will show this is a trapezoid. Okay, by showing that the sides are parallel. Well, let me change that a little. By showing one pair of parallel sides. All right, and in parentheses I'm going to put same slope. And actually that part I put in parentheses, that's the most important part. When I'm grading this and I glance across your introduction, I'm looking for the fact that you're going to show that the slopes are the same. Okay? That's the key. So that was the introduction. Now here comes the main body where I simply do what I just said I was going to do. So I need the slopes. And we need to find all of the slopes because we need to show that there's only one pair of parallel sides. So we need all the slopes. So let's go ahead and go in order. So I'll do A, B, B, C. I'll just go in order. All right, so your work will look like this. Slope AB. Slope BC. Slope CD. And slope AD. And so this is just rise and run. So when I go to do slope AB, I'm looking at this right here. What's the rise and what's the run? Can you count the squares for me? Is that 6? Yeah. Okay, and the run is 3. Okay? Very important. AB, is this a positive slope or a negative slope?
Negative.
It's negative because it goes downhill from left to right. Okay, so this is a negative 6/3, rise over run. Okay, negative 6/3, which obviously equals -2. Now, BC. Okay, so here's BC. Oops. The rise is 4, and the run is 8. Okay, so that's 4/8. Is this positive or negative?
Positive.
Positive is uphill. All right, so I have 4/8, which is 1/2. Okay, slope CD. Okay, so slope CD is like this. There's the rise, and there's the run. How high is that rise? 8. So 8/1. That's the slope, right? Is this positive or negative?
Positive.
It's positive. It's going uphill. Okay, so it's 8/1, positive. Okay, which of course is simply 8. And then finally AD. All right, so AD is right here. Okay, so that is, the rise is 2 and the run is 4. Is this positive or negative? Positive. All right, we've got a lot of positives here. Positive 2/4. Correct. Positive 2/4, which is 1/2. So as you look across all of these slopes, what do you notice? All right. Let's see. BC and AD. Those are the only ones that have the same slope. So that means one pair of parallel sides. So we're ready for the conclusion. So since there is only one pair of parallel sides, since there is, or maybe I'll say exactly, since there is exactly one pair of parallel sides, this is a trapezoid. All right, so that is how you go about proving that these shapes are a trapezoid or a rhombus or whatever it is. Strike one, Alejo. Keep your head all the way up in this. That's not even good enough. There you go. That's better. All right. Now, before I stop this video, let's talk about this category over here. Use calculations and words to demonstrate one property that must be true about the diagonals of a quadrilateral. This makes me go, why is this a head scratcher? There are no properties. There were no, look, they're all right here. We didn't check off a single one. So this one is not applicable. Let's put a giant NA on this one.
No. Oh.
No,
Okay.
not applicable. It doesn't apply to this particular problem. This will be the one shape where you can't do anything with the diagonals.